Today we're looking at Lesson 5.4 on solving compound inequalities. Compound means more than one. We have two types of compound inequalities. One is considered an intersection, which would have the word and, or I'll show you another way that you might see it. And then one is called a union, which would have the word or in between the two inequalities. So for this one, we're asked to solve, and this is a compound inequality, as there's two inequalities. It's separated by the word and. So basically, we're going to solve each inequality separately. So the first inequality is y minus 3 is greater than or equal to negative 11. So we're needing to add the 3 to both sides to get y by itself. We don't need to flip the symbol. So we're keeping it as y is greater than or equal to negative 8. Then we would need to solve our other inequality, which you would need to add 3 also to both sides to get y by itself. Again, we're not flipping the symbol, so it's y is less than or equal to negative 8. If I were to graph this, I would need to graph both inequalities on the same number line. So we have y is greater than or equal to negative 8, and y is less than or equal to negative 8. Oh, whoops, I made a mistake. It would be negative 8 plus 3, so that would be negative 5. Whoops. So y is less than or equal to negative 5. So these are our two answers. We would draw a number line, and we need to graph both numbers. So we need to make sure both numbers are included on our number line. And we need to put a closed circle at both numbers, since they both have an equal to, which includes them. And then we would need to follow the symbols for each arrow. What you will notice, though, is that with and inequalities, you're always going to have the arrows going towards each other. Okay? So you would have y is greater than or equal to negative 8, which would need to go to the right, and then you would have y is less than or equal to negative 5, which would need to go to the left. Another way to write the answer would be to put y in the middle and then put the symbols on each side to describe the same answer. So this answer would be the most proper in terms of our final answer, but it also reads the same as these two answers would read separately. So you would need to graph and then also write your answer. We're going to do another one. Here they actually put the inequalities together, so you're needing to solve for r, but you need to solve for r on both sides, which I mean, if I need to get r by itself and subtract 7, I need to subtract 7 from the 10 and also from the 6. So I rewrite everything the way that it's written, since I didn't do any multiplying or dividing by a negative, because that will still apply when it comes to flipping symbols. But in this case, we don't flip any symbols, so I leave it the exact way that it's written. And then I'm going to graph it. And if you're reading from the variable, you have r is less than 3. So you would put an open circle at 3 going towards the left, and then you'd have a closed circle at 1, negative 1. And that reads, if you're reading from the variable, r is greater than or equal to negative 1. So that would go towards the right. And like I said before, again with and inequalities, inequalities that are written like this or are separated with the word and, you're always going to have the lines overlapping each other. So they're going to intersect, as you can see here on the number line. Here we're solving for the word problem, so we need to write an inequality, a compound inequality, and graph it. So this company is manufacturing an action figure, and it must be at least 11.2 centimeters and at most 11.4 centimeters tall. We need to write and graph a compound inequality that describes how tall the action figure can be. So if we think of it at least and at least would be greater than or equal to 11.2, and at most would be less than or equal to 11.4. And since we don't know how tall the action figure is, that is going to go in the middle. We don't need to actually do any solving here, so we're just going to graph it. So we put a closed circle at both numbers, and 11.2 is going to be greater than or equal to, so that goes to the right. 11.4 is less than or equal to. Again, I'm reading from the variable, so that would go towards the left. Here we're asked to solve, and here you can see that it's separated with an or. So the same rules would apply. We're going to solve each separately, but we're going to keep our answer separate this time. So A would be less than 3, separate it with the word or, and solve the other one. A would be greater than or equal to 4. And this would be my final answer. And I can't put it together because we have two different scenarios. So it would be just separated with the word or. If I were to graph this, I have 3 and 4 as my two numbers. So I still need to make sure they're both on the number line. I would put a closed circle at 4, and it's greater than or equal to 4, so we go towards the right. And I'd put an open circle at 3, which is less than or equal to, so that would go towards the left. And this would be how all or inequalities would look like on a graph, where both lines are not intersecting and they're going in opposite directions. Here we have another one. This first one, we don't need to do any solving, so I'm just going to keep it as x is less than or equal to 9. Separate it with the word or, and we need to solve the second one. Get x by itself. So x would be less than 2. So this would be my final answer. And again, I need to graph them. So I'd put a closed circle at 9, and that is less than, so that is going this way. And a closed circle at 2, which is also less than. So you will see that sometimes the lines will go the same direction when it comes to or, but they would never intersect. They would meet with each other eventually, but then they would never intersect like the ands. And that concludes our lesson 5-4.